Who are you?
We are the knights who say...
No, not the knights who say ni.
Now, before we actually go through an example of graphing sine and cosine, we need to understand what the behaviors of these graphs are, what they look like, their domains and range, and key values, things like that. Now, first off, the graph of sine, you should be familiar with all of these, but I'm just going to go through them rather quickly. Sine, which starts at its 0 value, goes up to its maximum, turns back around, and comes back around. That's one cycle of the graph of sine. Now, recall that sine and cosine are periodic, meaning that this cycle will then repeat infinitely in both directions. So it's constantly cycling back around through this exact same process. And for the normal graph of sine, it has a period of 2 pi, meaning it completes this cycle after 2 pi, a distance of 2 pi. Halfway through its cycle would be here at pi, and at the beginning of its cycle over here is at 0. So that's the normal graph of sine. Whatever its period is, this kind of symmetric version of the graph kind of occurs halfway through its period. For cosine, rather than starting at 0, starts at its maximum, has pretty much the same behavior as sine. In fact, it's actually just a shifted over version of sine, but that would be that, completing its cycle after 2 pi. Now recall that it is also periodic, so it will continue infinitely in both directions as well, infinitely repeating the cycle. So over here is pi, here's halfway between that, which is pi over 2, and here is 3 pi over 2. Now for both of these graphs, the domain and the range are the same, because they're pretty much the same graph. The domain of trig graph is all real numbers, and its range is from -1, including -1, up to 1. So it bounces between the values 1 and -1. Similarly for cosine, its domain is also all real numbers, and its range also from -1 to 1. Now, that doesn't necessarily mean that all graphs of sine and cosine are between -1 and 1. Depending on what their amplitude is, this graph gets stretched out, and it could have a larger range. It could also be moved up and down, and left and right. So we're just looking right now at the behaviors of sine and cosine. Now, the graphs for negative sine and negative cosine are pretty much the same graphs, only reflected. So it's the sine graph, which starts at its 0 value, then it's going to go down to a minimum, and back around, and again continue infinitely in both directions, repeating that same cycle. It's just the same graph flipped over. And for cosine, it'll start at its minimum, go up to its max, and then back down to its minimum. So there's the behaviors of these sine and cosine graphs, repeating this pattern infinitely in both directions. So now, before we actually get to graphing a trig graph, we need to identify some key parts of it. Those key parts are the amplitude, which is basically the stretch of the graph and is represented by that letter A, the coefficient in front of whatever the trig function is. In this case, it happens to be sine. Could also be cosine. Also the frequency, represented by the letter F, and it happens to be the coefficient of the x value. The frequency is also related to the period. Oops. Let me just fix that. Frequency is related to the period. And the frequency is also related to the period, which is 2 pi over the frequency for sine and cosine. So whatever that number is for the frequency, if you divide it into 2 pi, you'll get what the period is. We have our phase shift, which is basically movement left and right. Okay, it's represented right here by the PS for phase shift, and we have the midline, which is basically shifts up and down. The midline of the graph, which is movement up and down for the graph. Now, let's take a look at an actual example and see how we would go through graphing things once we've identified these parts. So, for the first one, notice that since it is a negative value, my graph will follow the negative cosine graph, which looks much like this. So there's my behavior of the graph. My amplitude for this is the coefficient in front of the cosine, which is 3. So my amplitude is 3, which means I will go 3 units above and 3 units below my midline, which we'll identify in a minute. In order to identify the frequency and the phase shift, here's what you have to do every time you have one of these examples. I'm going to rewrite this in factored form for the stuff that's inside that cosine. Notice that this frequency is factored out of the phase shift in order to read off the phase shift. Now you can read the frequency off fine, it's just that coefficient of the x stuff, but in order to appropriately read the phase shift, we're going to have to factor it. So I'm going to rewrite this example right underneath it. You have y equals -3 cosine of, there's a common factor of pi, x plus 2 minus 5. So now I'll be able to appropriately read off that phase shift when I get to it. So amplitude, the frequency, is pi. It's the stuff that's in front of the x, which means my period, which is 2 pi over the frequency. So 2 pi over pi, pi's cancel out, gives me 2. My phase shift, now I can read off, is actually just the 2 here. It's 2 units, and since I'm adding it, it's going to be 2 units left. And my midline is 5 units down since I'm subtracting. So it's 5 down. Okay, so I identified each of my parts. Now I'm going to go ahead and begin graphing this. I'm going to start off by sketching some key values. I'll actually do it with this dotted line here. But since I've moved 2 units to the left, I'm going to draw a dotted line. Oops, go back. I'm going to draw a dotted line. Actually, I'll just use this. To the left 2 units. So that'll be here. And since I've gone 5 units down, I'm going to draw a dotted line 5 units down for my own personal reference. Okay, and then I'm going to set my scale. I'm going to do that. Set my scale here. So this is 1, 2 units back. Okay, so this is 1, 2, 3, 4, 5, 6, 7, and so on. And this is 5 units down, so that's 1, 2, 3, 4, 5 units down, 6, 7. So this is -5 is right here. And then we'll go 1, 2, 3, 4, 5 up, 6. Okay, so there's my scale. I have it all set up now. My period is 2, which means that my graph will complete 1 full cycle in 2 units. So I'm starting here. Since my amplitude is 3, that means I'm going to go up 3 units, 1, 2, 3. So my maximum value will be here at this point, and my minimum value will be down 3 units. So here's 5, 6, 7, 8. So here's down 3 units here. So I'm just going to do some little marks so I know where they end up. Since it's a cosine graph, it's going to start at its max, but since it's a negative cosine, it'll actually be at its minimum. So my starting value will be here, and it will complete 1 full cycle in 2 units. So 2 units brings me to here. So that's 1 full cycle. So halfway through that cycle, it will have gone up to its minimum, and my cosine graph should look something like this. Now I asked for 2 full cycles, which means I'll have to do 1 more. So it'll complete another full cycle in 2 units. So from here, it will come all the way back around to that point when I get to 2 again. And halfway between there and there, it will get to its minimum, which will be here. So then I have my cycle again. Okay, so that's actually 2 full cycles. Now recall that since it is infinite, it goes on further past there, so it looks like I actually didn't need all this extra graph space over here, but you could have continued graphing if you want to. Since I only asked for 2 cycles, that's all you have to graph, and that's my graph of -3, y equals -3 cosine of pi x plus 2 pi minus 5. I can't reiterate this enough, but remember that if you're going to read off your phase shift, you have to first factor out your frequency, so I rewrote it this way so that I could read off the correct phase shift. So don't forget to do that. That is essential to success.
It might be a tumor.
It's not a tumor.